Number 12 wire was commonly used in homes constructed prior to the 1960s. It is a smaller gauge wire compared to the number 10 wire that is typically used in modern residential electrical systems. As a result of its smaller size, number 12 wire has a lower current carrying capacity than number 10 wire. This difference in current capacity can present challenges if the home has undergone renovations or upgrades involving the addition of new appliances or electrical devices that demand more power. These modern devices may draw more current than the number 12 wire is safely rated to handle. In some instances, number 12 wire may be utilized in conjunction with a larger gauge wire such as number 10 wire. This type of connection is often referred to as a pigtail connection. In a pigtail connection, the larger gauge wire, such as the number 10 wire, is connected directly to the electrical panel. The smaller gauge wire, in this case the number 12 wire, is then connected to the electrical device or appliance. This type of connection can be a safe and effective method for connecting devices to the electrical system, but it is crucial to ensure that all connections are made properly and securely. If there is any uncertainty regarding the presence of number 12 wire in a home's electrical system, a visual inspection of the electrical panel is recommended. The wire size is typically stamped or marked on the circuit breakers or fuses within the electrical panel. This marking indicates the size of the wire that is connected to that particular circuit. If it is determined that the home does indeed have number 12 wire, an upgrade to number 10 wire may be a worthwhile consideration. Upgrading to a larger gauge wire such as number 10 wire can help to ensure that the home's electrical system is both safe and compliant with current electrical codes and standards. It is always recommended to consult with a qualified electrician to assess the electrical system and determine the best course of action for any necessary upgrades or repairs. A qualified electrician can evaluate the existing wiring, assess the electrical load demands of the home, and provide recommendations for improving the safety and performance of the electrical system. When dealing with electrical wiring, it is always important to prioritize safety and adhere to all applicable electrical codes and regulations. Attempting to work on electrical systems without the proper knowledge, skills, and experience can be dangerous and may result in serious injury or property damage. Always seek the assistance of a qualified electrician for any electrical work to ensure that it is performed safely and correctly. Understanding wire gauges is fundamental to electrical work. The American wire gauge, often abbreviated as AWG, is a standardized system for denoting the diameter of round, solid, non-ferrous, electrically conducting wire. The larger the AWG number, the smaller the wire diameter. Therefore, a number 12 wire is smaller in diameter than a number 10 wire. This difference in diameter directly affects the wire's current carrying capacity, which is the maximum amount of electrical current that the wire can safely conduct without overheating. Overheating can lead to insulation damage, fire hazards, and other safety concerns. The National Electrical Code, commonly referred to as the NEC, provides guidelines for the safe installation of electrical wiring and equipment. The NEC specifies the allowable ampacities, which are the maximum currents in amps for different wire gauges and insulation types. These ampacities are based on factors such as the wire's insulation temperature rating, the ambient temperature, and the number of current carrying conductors in a raceway or cable. For example, according to NEC Table 310.15b16, number 12 copper wire with a typical insulation type such as THHN or THWN is generally rated for 20 amps, while number 10 copper wire with the same insulation types is rated for 30 amps. These ampacities are based on specific conditions and may need to be adjusted based on other factors as outlined in NEC. When selecting the appropriate wire size for an electrical circuit, it is essential to consider the load that the circuit will be carrying. The load is the amount of electrical power that the devices or appliances connected to the circuit will draw. The load is typically expressed in watts or amps. To determine the appropriate wire size, the load must be calculated and the wire must be selected with an ampacity that is equal to or greater than the calculated load. It is also important to consider any future load increases that may occur. If there is a possibility that the circuit will be used to power additional devices or appliances in the future, it is prudent to select a wire size that is large enough to accommodate the anticipated increase in load. This will help to prevent overloading the circuit and creating a safety hazard. In addition to wire size, the type of insulation used on the wire is also an important consideration. Different insulation types have different temperature ratings, which affect the wire's ampacity. The NEC specifies the allowable insulation types for different applications and environments. It is important to select an insulation type that is appropriate for the specific conditions in which the wire will be installed. For example, if the wire will be exposed to high temperatures, a high-temperature insulation type should be used. When making electrical connections, it is crucial to use the proper connectors and techniques. Loose or improper connections can cause overheating, arcing, and other safety hazards. All electrical connections should be made in accordance with the NEC and the manufacturer's instructions. Wire connectors should be sized appropriately for the wire gauge and type being used. They should also be listed and labeled for the intended application. When splicing wires together, the connections should be mechanically sound and electrically conductive. Wire nuts, crimp connectors, or other approved splicing methods should be used. The connections should be tightly secured and properly insulated to prevent shorts and ground faults. In addition to proper connections, it is also important to protect wires from physical damage. Wires should be run in conduit, raceways, or other protective enclosures whenever possible. This will help to prevent the wires from being damaged by abrasion, impact, or other hazards. Wires should also be supported properly to prevent sagging and strain on the connections. When working on electrical systems, it is essential to follow all safety precautions. Always turn off the power to the circuit before working on any wires or equipment. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical systems in wet or damp conditions. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents. In older homes with number 12 wiring, it is important to be aware of the limitations of the wiring system and to take steps to ensure that the electrical system is safe and up to code. This may involve upgrading the wiring, replacing old or damaged components, and ensuring that all connections are properly made. Consulting with a qualified electrician is the best way to assess the condition of the electrical system and to determine the appropriate course of action. They can inspect the wiring, evaluate the load demands of the home, and provide recommendations for improving the safety and performance of the electrical system. Remember that electrical codes and standards are constantly evolving, and it is important to stay informed about the latest requirements. By following the NEC and other applicable codes and standards, you can help to ensure that your electrical system is safe and reliable. And again, always prioritize safety when working with electricity. If you are not sure about something, it is best to consult with a qualified electrician.